Okay, this is our last example. This example is a little bit different. It is in factored form already, but you will notice that there is a negative 1/2, which I almost erased, a negative 1/2 right here out in front. So we are going to have to make sure that when we are graphing this, that we don't forget. That is telling us that we have a parabola that is opening down, and our vertex will be a maximum. So let's get to it. Let's find our x-intercepts, and our x-intercepts are pretty much already there. We will need to have all of our y's equal 0, so we set this equal to 0. We have negative 1/2 times x minus 8 times x plus 4, and we put each part of those, each part equal to 0, and solve. In the first one, you will notice that negative 1/2 does not equal 0, so that is not a solution. We add 8 on both sides here, and we get x equals 8. We subtract 4 on both sides here, and we get x equals negative 4. So our x-intercepts are 8, 0, and negative 4, 0. I'm going to go ahead and erase all the work, so we have space for everything else, and graph those points. Negative 4, you can notice our graph has a different scale. Each grid mark is 2, so negative 4 is here, and 8 is right here. And there we have our x-intercepts. The next thing I need to do is find my axis of symmetry. And the axis of symmetry is taking the x's, x sub 1 plus the x sub 2 from our x-intercepts and dividing it by 2, which gives me 8. 8 minus 4, don't know why I wrote that again, which is 4 over 2, or 2. So my axis of symmetry is x equals 2, and I can go ahead and put that in over here, remembering that each grid line is worth 2. And this is x equals 2, RAOS. All right, moving on. The next step is our vertex. The vertex is the highest point. It's our maximum for this graph, and we plug in, since it is on our axis of symmetry, we plug that 2 into our function. So this is negative 1/2 times 2 minus 8 times 2 plus 4. It works either way. If you have it in factored form, vertex form, or standard form, you can still plug that x in. And you're left with negative 1/2 times negative 6 times 6. Negative 1/2 times negative 6 is a positive 3, and 3 times 6 is 18. So our vertex is 2, 18. Let's plot that, 2, 10, 12, 14, 16, 18 right here. All right, we are getting closer. The next thing we need to do you remember what it is? It is finding our y-intercept. The y-intercept is when x equals 0, so we will do the same thing we did for the vertex, but this time we'll plug in 0 for x, and we get negative 1/2 times 0 minus 8 times 0 plus 4, which is just negative 1/2 times negative 8 times 4. Negative 1/2 times, what did my thing do? Okay, negative 1/2 times negative 8 gives me a positive 4, and 4 times 4 is 16. So my y-intercept is going to be, or is, 0, 16. And we'll plot that, 10, 12, 14, 16. And last but not least, let's find that reflecting point, which should be pretty simple here. So if we zoom in, we can see that our y-intercept is 1 unit or 2 from the axis of symmetry. So we will be plotting our reflecting point 2 units or 1 grid mark to the right. And that is, let's see, 2, 4, 16. Oops, I did that wrong. I just said it was 4. 4, 16. And there you have it. Let's plot in my fun rainbow color. And we're going down this time. Rounded. Voila, we've got it.